All right, so welcome everyone to Science in Action. Today is October 13th, 2020. Want to welcome everyone on the call here for another Science in Action. This time it is my distinct pleasure to introduce one of our very own from the STEM Center, Mayra Lopez-Thibodeaux, here to share her educational journey as well as some of her current research. But without further ado, I want to just hand it over to Mayra.
All right, thanks, Brian. Hi, welcome everyone. I'm really happy to share with you my adventures and my educational path and research. And so I hope I don't lose you too much. Because this research was in particle physics, and I actually had to learn a lot myself when I came to it as an intern. And so if you allow me to share my screen, I'm gonna go ahead and share my presentation. And so for this talk, I was asked to talk half of the presentation about my educational journey, the hurdles I went through when going to school, and a little bit about my personal background. So I decided to name this presentation after my favorite research project, which I'm gonna build on to later on in the second half of the presentation. And this is about trying to understand our universe via the general antiparticle spectrometer in the search of dark matter. So what this experiment is pretty much a balloon-borne experiment for the indirect detection of dark matter. And I'll tell you a little bit about it later on. But in this presentation, I'm gonna tell you first a little bit about my personal background, my educational path, the challenges I encountered during this path, a little bit about the research experiences I've had, and then I'm gonna go deeper into one of those research experiences, which is the prototype of the general antiparticle spectrometer. So I grew up in Mexico. I lost my father at a very young age, and so I grew up with my mother and 4 siblings. Even though my father was an airplane pilot, I didn't get to know him much, of course, because I lost him. I was very young when he died. I was only 3. And so my mother only went through the 7th grade, I believe, of school. So my mother, even though she was an avid reader who dreamed in going to university, she was from a very small town, a conservative family, and her family didn't believe on sending women to the university. They were a little bit afraid about sending them by themselves to the city. It was far away. And even though my grandmother believed in education, they just believed that it was a better move for women in the family to just get married and have children. And so that's what my mother did. And so I moved to San Francisco as a young adult from a highly family and friend-oriented culture. And so imagine the cultural shock I went through coming from a family-oriented, family and social-oriented culture to an individualistic culture. I really felt like people were very much into themselves. Sort of, I felt this feeling of, I had this feeling of isolation. So sometimes I even took it personally, thinking that they were being rude because I was different. But then I found out through making friends in the United States that it was just a different culture, right? It was a difference in cultures, perceptions, expression. And so that was very enriching to me and very eye-opening. I was living with my mother all this time until a young age, which is very customary in my culture. So I didn't get to know much about, outside of my country, my culture, my house. And so I came to Skyline to learn English. And then later on in my college years, I discovered what physics was about. I had no idea what physics was about until I came to college in the United States. So I'm gonna post after every slide to see if there are any questions. And so feel free to bring them up any moment. And I will do a little post in case there's anything that comes up. So for my educational path, I think that my path through school was highly influenced by my mother's passion for reading and learning new things. It was really hard for her in her small town to actually get new books, but actually family members who would travel knew about her passion to reading, and she got lucky in the fact that they started learning that about herself, and they started bringing books from the city for her to read. So and then as I was growing up, she of course read to us. She tried to always maintain a library of very interesting books or encyclopedias for animals or plants or whatever our interest was at the moment. And I really thank her for her, because it really woke up in me an intellectual curiosity. And that just grew up with the years. And then I also learned about the importance of having an education to succeed in life, to do what you really wanted to do at work. So the first 3 years at Skyline College, I concentrated in English because I spoke nothing. I spoke zero English when I came, even though I knew some words, how to write some words, and I understood a little bit when reading it. I just couldn't talk. And so, so I completed my general education studies at CSM and Skyline together. Why College of San Mateo? Because I was able to get a full-time job there near College of San Mateo. So it was just easier for me to commute to College of San Mateo rather than Skyline. But I always liked Skyline much better. It was really my alma mater, and what really got me through the cultural shock of coming to America. And I had my friends there. And so it was really helpful to have that little community in Skyline College. So when I kept going with my education in college, I was fascinated when I took physics and astronomy courses. Astronomy really got me going into further my education. I still remember my professor at CSM. He's still there. There is Stanford. He was so passionate about astronomy and so into teaching students and showing them the relevance of the physics in the cosmos. So I decided to transfer to San Francisco State University with the idea of getting a bachelor's in arts in astronomy. But as I was studying, my courses, my general courses, I was really curious about not only observing the phenomena in the cosmos and knowing about it, but understanding why things work that way in the cosmos. It just threw my mind the way that it was empty. It was the void, right? With all these interstellar gas, stars, and celestial bodies interacting with each other. And so I wanted to know about the natural dynamics in general of the cosmos. And so I decided to switch my career goal about the second year of my undergraduate studies to a bachelor's in science in physics with concentration in astrophysics. And I did graduated with this bachelor's degree in 2012, 2 years after. So, and then farther on, I kept going with research. I was fascinated by the existence of dark matter. And so I was really curious. And so I decided to keep going with experimentation and research. And so in one of my projects, it really sparked my interest for applied astrophysics. And so I decided to go to San Jose State 3 years later after graduating 3 or 4 years, something like that, to pursue a master's in aerospace engineering. And that's where I'm at right now, actually. So any questions about my educational path, feel free to ask. Otherwise, I will continue with the challenges that I encounter throughout my education. And of course, that starts with the loss of my dad at 3 years old, which really created a lot of insecurity in my family, not only emotional because of his loss and his forever absence from the family, but also economically. It was really hard for a very underprepared mother to find a decent job to sustain the family. And so when I hit my teenagers, there was no way I was able to afford going to university. So it was all for me. I went into working. I was thankful though that I was able to complete a emergent program with high school and what is equivalent to an associate's degree in Mexico. And so, but I actually hated what I did there, the associate's degree I got. It was corporate tourism business administration. And I went into working for some time trying to support my family. And I enjoyed the tourism part of it, but not the administration part of it. So it was a great opportunity for me when I was able to come to the United States with the interest of keep helping my mother. So I came to help one of my uncles in his business here. And so that gave me the opportunity to make money to help my family and at the same time learn English. And so I took it one step at a time. I first thought, okay, first I'm gonna start by learning the language and see what happens. And so I did, and I came to the nearest community college to my home. Which was Skyline. And of course, the language and barrier and cultural shocks were forever a hurdle for me. And it still is. As I talk to you, I wish it would be in Spanish. And I'm always afraid that I'm gonna cross the words, I'm gonna confuse the meanings, I'm gonna forget my English because I get stressed and forget words. So it's always something that one as an immigrant has to fight. English, a second language is never like your native language. So, but I'm really thankful to be bilingual. So, and as for the cultural shock, even though I've fought a lot to try to adapt, I still see lots of differences in my way to communicate. Sometimes my words don't come across the same way. And so, yeah, that's even though I feel enriching being bicultural, I sometimes wish I would have grown up here so I could better understand people and how to communicate more effectively, get my feelings and ideas across better. And so, but in the beginning, I do remember getting out of the bus in Skyline College, my first day of class. I was so afraid. I was so frightened. Everything, it looks like Mars to me. It looked like a different world. It was just, everything was so new to me. And I was so afraid of people because of course I couldn't speak even a word. But it was very helpful in one way to have made Latino American friends who helped me overcoming the cultural shock. They taught me about the culture and the people here. They taught me about, being more cosmopolitan and keeping an open mind. And so another weird thing, that weird situation that I was at when I first came to Skyline was that it's that in my first years of college, I was actually an undocumented student. And so that puts you in a very weird situation where it makes you feel like you don't fit in. You don't deserve being here. You don't deserve being at college and having the resources that students have. And unfortunately, as a young adult, many immigrants feel that way. And most of us actually did. Whoever, I knew between my friends that they were, because we all hide it, actually. It's something that it's not discussed because you feel fearful. So I feel fearful up to a certain point, rejected. And so, of course, I didn't look for any opportunities nor resources. And I was having to work a full-time job while taking at least 12 units. And so that went well for some years. I did pretty well at college in the beginning. And then when I transferred to San Francisco State, my mother had a huge stroke, and she became highly dependent on me and my siblings. She lived with me for a few years, and I actually had to take care of her, sort of like a 3-4-year-old. And so I didn't have the opportunity to choose the university I was going to go. I just chose whatever was closer to home to make it work. And so that was San Francisco State University. And so I transferred there, and I will go back and forth. I would just go to school to take my classes, ask questions during office hours to my professors, and come back to take care of my mother. I do feel really fortunate that I was able to be with her and help her. But, you know, seeing your mother with that acute disability, semi-paralyzed, thinking like a 3-year-old or 4-year-old person, really leads to some anxiety and depression on the long run. And so during my graduate studies, her health declined even more. She was about to die twice during my 4 years at San Jose State University. I'm still there, but I'm now doing my project, my master's project. So it's better to do work independently. But when you have, you know, a heavy load of classes and having to commute all the way to San Francisco, I live very close to Skyline College, it does become really challenging when your mother is in such a acute disability state, and her health is declining, and you don't have time to be with her. You know that she's going to leave anytime, and yeah, so that really added a lot of time to my school, to my career. And so I eventually fell sick, and so I had to deal with my illness too. But I overcame all that with a little bit of help. Actually, I think I'm going to mention this for those who feel, you know, understood by my experiences or acquainted to them. Something that really helped me was seeking for help at school. My very high anxiety levels were really messing up my grades, especially during test taking. And so I went to the Accessible Student Center, and they guided me a lot. I was able to take some therapy, take some extra help, and it was wonderful. It helped me so much to better cope with my feelings, my stress. I learned I had a very good excuse to be stressed and depressed and anxious. And that by itself just helped me digesting everything, and I was able to keep going. So use the resources you have at hand. And if you are here with no documents, you still have the same rights. Word is the word, wherever you are. And you have the right to be wherever you want in the world, because it's our world. So having said that, I'm going to mention a little bit about the research projects that I've been so fortunate and blessed to have participated. And they all have been a blaster. I've had these very fun adventures, which I might mention if I have to. I think I'm doing good with timing. So I started research in 2010 in my second year as an undergraduate, when my Big Bang theory professor invited me to collaborate with him on the research on the distribution of dark matter within clusters of galaxies. And we did this research taking the observational astrophysics approach, where we were actually analyzing data gathered by the Hubble and Hawaiian telescopes. So that was really fun. And I hope I can share some more about this research with you in other talks. But for the sake of time, I'm just gonna go briefly through all these experiences, and then I'm gonna deep more into one of them. So the following year in 2011, I went to the Berkeley Space Science Laboratory under the sponsorship of my professor. And in there, I collaborated in the integration of the general antiparticle spectrometer prototype, which I told you about in the beginning. And so I will tell you more about this in the second half of my presentation. The following year, I went to Lawrence Berkeley National Laboratory through a internship program. And in there, I did some research and development for a dark matter detector using a pixel readout integrated circuit connected to a time projection chamber, which is pretty much a tiny gas camera with a detector connected to it, using gas avalanche from the ionization of cosmic rays coming and interacting with the gas molecules in the gas camera. And so presently, I'm in San Jose State University doing research for my master's project in artificial neural networks training to correct for solar gravity perturbations in close orbits. This means when the satellite is orbiting around, let's say, Venus, the gravitational potential of the sun pulls that satellite, right, that spacecraft towards it. And so it's a fight between the gravitational potential of Venus and the sun. So we're trying to correct for that, trying to use artificial neural networks, which is a type of artificial intelligence. And so I hope I can tell you more in the future about it. Right now, it's still under development. Any questions so far? Okay, so I'm gonna proceed to talk about the GAPS prototype.
Sorry, Mayra, we just had a question come into the chat.
Sure.
So we have your passion taking care of your mom during declining years. My mindfulness respects. May I ask you a question? Can spectrometer applied in medical devices, meaning spectrometer adding to ultrasound?
Yes. So what was the question, sorry? How it compares?
Oh, okay. For the second half of the question came through. So can spectrometer applied to medical devices, meaning spectrometer adding to ultrasound, could measure like the lung and the respiration? Do you have any comments on that?
Do you know, I assume it will, because a spectrometer, all it does is pretty much looks into spectra. And so it reads out and sort of like gives you a mapping of the electromagnetic spectrum that the signal carries on with it. And so I'm not sure about what's going on with the spectrometry in the medical field, but maybe Professor Kapp knows anything about it. No, so
not really.
yeah, I will be
There's always
happy.
new stuff coming in.
Yeah, but I believe there's some spectrometry going on in many fields of science, not only in astronomy and astrophysics. But thanks for your question, very interesting.
We also do have a question from Dr. Kapp. Were your internships paid, and did you present your data at meetings? And if so, which ones?
Yeah, I did. Very good question. I did present in all of them, but I didn't put here my presentations because of the sake of time. So the only one I didn't present with is for the San Francisco State University. And that was only because I went into doing other research. And so I had to leave that research aside. And so for the Space Science Laboratory, I did 2 presentations, one in Berkeley, and the second one was, where was it? I think it was in one Women in Science conferences in conference in Caltech, Pasadena, I believe. For the actually, I did more. I did 2 other for the General Antiparticle Spectrometer. I did 2 other for Berkeley Lab, and another one for where was this one? I'm forgetting the 4th one, but I did because I was for 3 years in Lawrence Berkeley National Laboratory, and so pretty much every year there were presentations coming up, and of course the group wanted to get the word out there about the experiment. And so so in summary, I did 2 presentations for Space Science Laboratory and 4 presentations for Lawrence Berkeley. I wrote papers for the both of them. 2 of them were published by Lawrence Berkeley National Laboratory Physics Group. And for San Jose State University, a paper that wants to be published is still under development. And so, am I missing part of the question? Did I? Oh, they were paid. Yeah, they were internships paid. And the pay is actually about $20 per hour, something like that. Yeah.
So are those internships still available? Do they typically hire people?
Yeah, they are, and I can send links later on because they changed names, and so I am gonna send. Yeah, that's a good point. I should have gathered the links, but I saw myself very short on timing, and so but I can certainly post those links for you. I'll look for the internship programs and send it to you. Hopefully, we can post it probably in Discord, or you can give it to your students. Thanks for your questions. Any other questions?
Yeah, we had one more come into the chat. So this one's from Jocelyn. How did you cope with your mother's illness and still taking classes and now also pursuing your master's degree?
I know. That was really tricky. You know, remember that you are much stronger than what you think, and make the best out of it. What I did is I seek for help. So in the Accessible Student Center in San Jose State University, they actually refer me to a therapist, and they ran some exams. I think it's educational exam, something like that, just to measure, you know, if there's something going on with your style of learning, what your stress levels, your anxiety levels are. And that test helped me a lot to my therapist to tackle how to help me. And so I went to therapy for, probably a year at least. And then my therapist also referred me with a letter for help in the Accessible Student Center. And so they were able to accommodate at least for help with the testing, because testing was a major problem for me at the moment because of the high levels of anxiety. And so that was amazing. I mean, they didn't only gave me a separate room, but also gave me a little bit more of time, and that make a huge change. I mean, my grades went up to A's, A minus, and so, which is really hard to get in an aerospace engineering program. And so it just had a huge impact. So do try to use the resources. Don't feel afraid to speak up. We all go through very tough times in our lives, and we all have different experiences. Some people are luckier than others. And so try to be try to be fair with yourself. Try to use the resources to put you at the same level and with the same rights and opportunities to the others. When my grades started declining, I thought, hey, this is not fair. I'm dealing with this and that and that and that in my life. It's not fair. The others are having a much better opportunity than I am right now in life. And I have the right to make it fair for myself. And so that's when I went to look for help. didn't think about, you know, these stigmas we have about taking therapies for crazy people. That's just a stigma. It's just the way how you perceive things. And so I highly recommend you to really be humble, be open-minded, and look for help when you need it. It's going to make a huge difference. So that's how I was able to cope with it. And of course, with the love of my family, the support of my loved ones, my husband, he's been great. He helped me all the way through. He taught me. I didn't have role models in my family. The women in my family were, you know, married women at a young age who had children, and that was it. That was life for them. And so my husband really helped me with that. So try to find people, try to surround yourself with people who are going to be like that, that are going to be supportive, believing in yourself, no matter the gender you are, your background or your ideas or beliefs. And so he played a big role on the support I had, and I'm really thankful for him. He's been helping me with my mother. And then later on, after I was able to get my mother a residency in the United States, I was able to get help from a nursing home, a very good nursing home. And that's also a way, the way that I was able to keep going with school. I wouldn't have been able to do it on my own. Yeah. Any other questions? I hope I answered your question. Let me know if I didn't, please.
No further questions, but definitely if you want to take a look at the chat, there's a lot of supportive and
Oh,
a lot
thank
of
you. Thank you.
gratitude for you sharing your story. Really inspiring.
Thank you so much. You know, sometimes it's hard, at least for me, to share these kinds of personal stuff, but I did it with lots of love and care for our students, because I know that you are out there in the same position as me, and I want to reach out to you if you're going through the same hurdles. And believe me, you can do it. You're strong and very smart, very smart. You just need to see it. You have to believe it. So I have to be fair with this program. I have to say that I did it during my years in San Francisco State University, great institution who helped me so much, who taught me so much. And I did it through the Summer Research Opportunity Program. This is one of the scholar internships I got, but it changed names, so I have to find you the new name. And probably if you Google this name, it's gonna come up with its new name. So I invite you to really do it, because it made a whole difference in my career. They gave me board, food, and good pay. And it was for a whole summer. It was 3 semesters, and they were very accessible, very kind. They did fun activities. We did fun activities together besides doing research. So it was great. And of course, it was sponsored by the Space Science Laboratory at Berkeley University, JAXA, Japan Aerospace Exploration Agency, and NASA. So now I'm going to start with the relevance to go through such hurdle to develop these types of apparatuses, right? Why, like, what do we know about dark matter, and why is it important? And this is what really got me when I learned about dark matter. Dark matter, it's actually 80% of the total matter in the universe. Can you believe that? We know nothing about matter. The matter that we are familiar with, and we know and see, it's only 20% of the total matter of the universe. So that 80%, it's dark matter. And of course, we don't know what it is, which is very ironic. We have no idea what it is. There are several candidates for it, posted by theoretical particle physics. And so it's called dark because it emits little or no dark or no light. And it's actually, it's not only 80% of the total matter of the universe, but it's also the glue that keeps clusters together, right? And one thing is that this particle physics theory actually proposes, just hold on a sec, proposes WIMPs as the major candidate for dark matter. So WIMPs are weakly, it stands for weakly interactive massive particles. It's possibly most of the dark matter in the universe. It's so so it's believed to be composed of neutralinos. Sorry for the pause. I got distracted for something on my window. So neutralinos, it's believed to be what supersymmetry or SUSY parts of WIMPs are. And so neutralinos are their own antiparticle, leading to their own co-annihilation in the atmosphere and even in the cosmos. So so the name of the particle physics theoretical model that suggests neutralinos is supersymmetry, abbreviated SUSY theory. And so even though WIMPs rarely interact with matter, they exert gravitational attraction. And so in here, I'm showing neutralino annihilation leading to SUSY antideuterons. So how do we know dark matter exists? So it acts as a glue for galaxies, for clusters of galaxies. In here, there's an artist rendition that shows how clusters of galaxies actually will be floating around, away from others. I should say galaxies, sorry, in the absence of dark matter. And so dark matter keeps them together and actually is highly responsible for the dynamics going on with celestial bodies within galaxies. And so the way we know that it exists is via this equation. So this equation is describes the velocity of a satellite orbiting a inner mass, in a big body of mass within its orbital radius. And so in here, if we observe this formula, we notice that the velocity of the satellite is proportional, is directly proportional to the square root of the mass, the inner mass that this satellite is orbiting. So instead that mass is the mass within the orbit. R represents the orbital radius of the satellite going from the center of the orbit all the way to the satellite. G is just the gravitational potential. And so the luminous mass detected from other galaxies doesn't account for the observed fast speeds of its stars. And equally, the luminous mass detected from clusters of galaxies doesn't account either for the fast speeds of the galaxies orbiting the cluster center. And so other unexplained motions in celestial bodies is that of stars within galaxies, such as stars orbiting a point in space at high velocities, faster speeds of stars farther from our galactic center, also suggesting that most of the matter in our galaxy is concentrated on the spherical halo that surrounds its disk. So, and we cannot see anything in this halo. So halo, it's like nearly a spherical blob of matter. around the bulge of the galaxy. And so all that matter that we cannot see dictates the velocity of these celestial bodies around that big mass. There's also another piece of evidence called gravitational lensing, which is the bending of light due to the distortion of space-time by mass. And this actually has to be a huge amount of mass to be able to bend space-time. And in here we can see it on the picture in the surrounding here. Gravitational lensing, it's actually shown here with these celestial bodies bending, with this part of the picture bending light in the darkness. And here we can also see it. I hope that you can appreciate these. Any questions so far about these?
Nope, no questions in the chat. Oh. Sorry, I only see a partial question on the chat, so I'll wait for the rest of it to come in for the next slide.
All right. So now I'm going to tell you a little bit about the detection in the GAPS detector. So the detector, the GAPS detector is designed to detect low energy cosmic ray antidurons, pretty much a bunch of antidurons, which are one of the hypotheticals, as I said before, it's one of the hypothetical byproducts of neutralino coannihilation. So the heart of the GAPS will be, it's actually will be, because it hasn't been launched. The prototype was launched, but not the actual experiment. So it will be 13 planes of silicon lithium detectors, silicon lithium dot detectors, and a time of flight system with plastic scintillators and photomultipliers to measure the antiparticle's velocity and energy. So the antiparticle is expected to be stopped here by the solid Sealy tracker to form an exotic atom with the antideuteron in it, which will cascade down to ground level, producing well-defined X-rays and annihilate into a signature pion star. So this is what's going to give the signature of its detection. This is going to be a very well-recognized pion star and very well-defined energy, X-ray energy. And so that's what's going to recognize, be recognizable different from other particles. Antideuteron detection is a convenient approach because its signal barely has any secondary and tertiary contamination, as we can see here in this graph. In here is the realm that we are looking at. It's the energy level that we are looking at. So in here, there's not much interaction or background noise going on. And so the GAPS is expected to be launched from Antarctica in 2020. So Brian, did you get to that question?
Yeah, we do have the question, but in consideration with 10 minutes left, I want to make sure we have a time check.
I know, my goodness. So I'm going to have to go really quickly through this. This is the silicon detector prototype. Sorry, this is the GAPS prototype that I helped with the integration of. These are the golden plated boxes that hold the detectors. And what I did is, in here you can see the detector in the gondola prepared to be put in the balloon to fly at the upper atmosphere. And here is the tracker. This is the time of flight with its different layers. And behind there is the VME system, readout system. And so I'm gonna skip through these details. This is pretty much shows the power distribution of the PGAPS. powered by an electrical power distribution via lithium batteries, feeding up mainly the time of flight, the tracker electronics, and two DC-DC converters. And so the DC-DC converters go to the flight, shape the necessary signal to the flight computer and the time of flight. And the tracker electronics feed into the power supply and the SILI dot detectors. Then there's also an Ethernet box for the flight computer, the tracker electronics, and the time of flight communication, all interconnected. The housekeeping signal keeps track of the tracker's temperature, which is very important to keep the doping on place for the signal detection. And communication with the ground computer was kept by an antenna. Sorry to go sort of fast with this. I want to leave some time for questions, and we are hitting we are very close to the end of our hour. So this is a part of my work. In here, I measured the charge in the preamplifiers to measure the noise. And so the way I did it was pretty much putting pulses through a preamplifier, and the input voltage was amplified, and then filter into the desired signal, the desired voltage, BP, and then read by an RMS voltmeter, which measured the voltage, and that measure was used to calculate the full width half max noise per channel in the system, in the preamplifier system. And so in here, I'm just showing the setup with the oscilloscopes. I used two DC power supplies corresponding to the ideal current to measure the noise and the input voltage. And then these, in here, I'm just showing the results of my experimentation with them. In here, I'm putting together the preamplifier boxes to be tested. And then in here, I'm just showing a table of the results. The data analysis was done with the framework, with data analysis framework root, which is very popular among physicists. And in here, I did a Gaussian distribution fit and the standard deviation used to calculate the full width half mass noise per channel. And so actually the full width half the full width half mass noise actually represented the resolution. Back then, we got a resolution between 9 and 5.5 kb, so more work was needed to reach the desired resolution of 3 kb. And so in here, I'm reaching my conclusion, and I'm just going to wrap it up with the very main parts of the experiment. So this experiment was set up for the relevance of the matter of the universe being composed mostly of dark matter. And it's designed to detect low energy antideuron, which is believed to be a byproduct of the main component of dark matter, hypothetically. And so the identification was done by well-defined X-ray depositions and a signature pion star. And as the antiparticle was stopped and crashed in a multiple layer of silicon dope detectors. So the prototype was launched into the upper atmosphere to measure stability and low noise for the SILI detectors, to check the performance of the cooler system and time of flight systems, and also to learn about the X-ray and particle atmospheric backgrounds. So as I said, the instrument was launched after the desired resolution was reached, and it was launched in Japan, in the JAXA aerospace research field in Japan, Gokaigo in Japan, and the flight lasted 6 hours. And a float altitude of 33 kilometers. And so they measure about 1 million cosmic rays that the triggers were recorded, and they actually reached the goals that they were trying to meet. So sorry to end with only 5 minutes for questions, but I feel free to stay and ask me questions. I'll save extra time if needed, so you can ask any questions.
Thank you so much, Mayra, for
Sure.
sharing your journey, some of your research and your insights. And just wanted to jump to some of the questions that were popped up into the chat. So first question is kind of what type of spectrometer are you using specifically? Is it a quadruple mass spectrometer or a tunable laser spectrometer or any other type?
So it's actually a, so the spectrometer itself is the detector, right? So it's pretty much layers of silicon that decompose the particle into all the way to annihilation. So this will be the actual spectrometer. And so it's a pretty different type from the ones that are used in other realms of science. And this is due because of the very high resolution needed to try to capture such a volatile and low interactive particle as it's believed to be dark matter. I hope that answered your question. Any help?
Yeah. So I also want to invite anyone else on the call to post any questions into the chat that we can redirect to Mayra, or we also have allowed any of the participants to unmute themselves if you want to ask Mayra directly. But in the meantime, I'll ask another question that popped up in the chat. Your take on What is your take on the Perseverance rover landing expected in early 2021 in Mars? And they hope that you lead a tour group at a NASA campus in Mountain View.
Can you repeat the question again?
Yeah, just your take or your perspective on the Perseverance rover landing expected in early 2021 on Mars.
Well, I think that, you know, what they're doing is really hard work. And for sure, we have a lot to learn about that. And they're actually trying to apply new science to that and develop the field. And so I'm definitely gonna try to follow that more closely to learn what exactly they're doing. But I think that this mission is mostly about trying to develop the field, the technology to get out there, not only to learn about the planet, but also to advance aerospace science, which is highly needed. And of course, I will be very happy to give you guys a tour to look into that.
We also had a question from Dr. Cap. Will you get to the launch? I'm afraid I'm lacking a little bit of context. Dr. Cap, if you care to elaborate.
So for the launch, I don't think so. I didn't keep contact with the group. Well, with some of the members of the group, I did keep contact, but I'm actually I'm not sure, how they're doing now. So I don't think I will get to the 2020 launch. I will follow their development, And I could certainly ask questions to the group if scientists that I collaborate with are still there. It'll be really cool to be able to go.
All right. So I'm just out of respect for everyone's schedule and timing, I'm going to conclude the recording here. But just like Mayra offered, she'll stick around the call and get a chance to answer or address any more questions and concerns that any of our participants may have. But for those of you guys that are watching the recording on YouTube, we invite you guys to join the Zoom call every Tuesday, 4:30 to 5:30. We'll be right here, and there'll be a link to access the Zoom call in the description. But that's your best chance of getting a chance to ask our presenters directly some of their experiences, their research, what they learned, and some of the wisdom that they might be able to share with you as you guys pursue your educational journey. So thank you guys all for your time. Really, really appreciate it. See you guys at the next Science in Action.